Hello again, general math students. In this video we're going to apply our understanding of bearings to a question in context. So here we have an orienteering course. So let's look at the important information in this question. So for starters, the orienteering course sends competitors 5.2 kilometers due north to a fire tower. Okay, so you might be familiar that if you're looking at a two-dimensional map, north is directly up the page, and that means south is down the page, and we have east to the right of the page and west to the left of the page. So we're going to have this first leg, which I've coloured in blue, going directly up the page. I'll get a ruler ready. So 5.2 kilometers due north. So we have the starting point, and competitors are going to go 5.2 kilometers to the north. So I'll mark that distance in. And when they finish that leg, they are at, or they reach a fire tower. From here, they're going, oops, a daisy. From here, they're going to turn due east. So that's to the right of the page. I'll just highlight that here. So 3.7 kilometers due east to an abandoned building. So that means they're going to go to the right of the page. Due east is directly to the right. I'll make that line a little bit shorter than the blue, the red line a little bit shorter than the blue line, because it's a slightly shorter distance, but it's not to scale, this drawing. And when they complete that leg, they reach an abandoned building. So in part A, we're asked to find the total length of this course. So that's going to include the blue and the red legs, those first two legs of the journey, or the course. But we know that they return to the starting point from there. So they return to their starting point, which means they're going to go from the abandoned building back to the start, like this. So we need to find the length of the black line, or the hypotenuse of this triangle. Let's just say D for distance there. We could call it X or D or whatever we like. And we need to calculate D and then add up the length of all three sides of this triangle to find the total length of the course. You might feel confident enough to pause the video at this stage and try and calculate D, and hence find the value for the total length of the course. So I'll give you a chance to pause the video now, then I'll have a go at it. Okay, so for part A, we're going to use Pythagoras' theorem. So D will be equal to the square root of the 5.2 squared plus the 3.7 squared. Now, if you have a go at that and round to one decimal place, which I'm going to do because all the numbers that are given in this question are to one decimal place, you get 6.1 kilometers. So the total length is those three sides all together, the 6.1 plus, and I'll stick to the colours even though you probably get the idea by now, plus 3.7. So the total length is equal to, what do we get there? 5 and 11.3, 14.3, gives us 15 kilometres altogether. Okay, so that's the total length of the course for part A. Now we're going to have a go at part B. So in this one, we're asked to find the bearing of the finishing point from the abandoned house. So that's the finishing point, which is the same as the starting point, back over here. And this abandoned house, or they say abandoned house, they've said abandoned building before. I think that's meant to be the same place, over here, right? So what we need to do is say, okay, if you're standing at the abandoned building, what angle, what bearing do you look back at the start or the slash finish of the course? So when we're doing bearings, that involves angles, so we need to know the angle at this part of the triangle. I'll just call it theta. Once again, you might feel confident enough to go and calculate that yourself and then see if you get the same answer as me. So pause the video now if you want to try that on your own, and then I'll continue after that. So I'll try it now. Let's make a bit of room, get rid of this bit here. Okay, so part B. Now, because we have all three sides of this triangle, we know now that this is actually 6.1 over here, 6.1 kilometres. You can use sine, cosine or tangent. Now, if you've done your calculation previous to this and used sine or cosine, that's fine, that's okay. I'm going to use tangent because that involves numbers that haven't been rounded off. So you might, I haven't checked the calculation, but you might get a slightly different answer to me, but that's not a big deal. So sine, cosine or tangent are okay, but I'm going to go with the two sides that were given, these two here. So that 5.2 is the opposite side to the angle, theta, and 3.7 is the adjacent side. So opposite over adjacent is the tangent of that angle. So tangent of theta is equal to, okay, so it's 5.2, the opposite side, divided by 3.7. So to rearrange to find an unknown angle, we take the tangent over and it becomes an inverse tangent. Alright, and if you put that into the calculator, this is what you get. I'm actually going to do this one because we need to convert to DMS. So just on the scientific calculator, shift tan, and then we have 5.2 over 3.7. So there is the decimal value, 54.566, so forth. But I'm going to push this button here. You can see, might be able to see me wiggling the cursor over that. That will change it into degrees, minutes and seconds. So it's actually 54 degrees and 34 minutes when we do that. Now that's not the final answer. We need to give this as a bearing. So if we consider that this angle is actually 54 degrees and 34 minutes in here, so if we think, okay, we're going to be looking due west in this direction, how far round to the south do we look? So we say west and 54 degrees 34 minutes. Beg your pardon. It's gone a bit funny on me. Just fix that up. 34 minutes towards south. Okay, so this is fine for this question, to give that as what we call a reduced bearing. But in fact, I'm going to do the true bearing, or the three-figure bearing for this as well, just in case you are asked to do that. Sometimes in general maths questions, they want the true bearing. They want to test you out a bit. Okay, so in order to get the true bearing, well, we need to give the angle from north. So I'll rub out some stuff here just to give us some space. So this is 54 degrees 34 minutes in here. If we were giving the true bearing, then we would need to go from north and find this angle from north around to here. So of course, if you consider that this all the way around to the red line, so starting at north all the way around to this red line here is 3/4 of a circle. Of course, that gives 270 degrees. So to find the grey part of this that I've traced out, this arc, that angle that's subtended by that arc, we would subtract the 54 degrees 34 minutes from 270 degrees. So 270 minus 54.34. Okay, these are tricky to do in your head, but with a bit of practice you can get good at them. So think about, okay, let's take the angle away, 54, so 270 take 54 gives 216. Now of course each 1 degree of angle is 60 minutes, so I'm going to take another 34 off 1 degree of angle, 34 minutes, so that brings me down to 215 degrees, and 60 minutes in a degree, 60 take 34 is 26 minutes. So that is the true bearing for this situation. Okay guys, so thanks for watching. Go ahead and check the questions in the description for the video and try some of these bearings questions where we're applying them in context.